Hello students, today we shall talk about how to determine the input power, the current and the cable rating of a cable and the rating of the fuse, conduit, distribution board, switches and the starters for the motor or three-phase circuits. Welcome, myself Tarakeshwari, Assistant Professor from EEE Department SJPIT, give you an introduction on how to determine these parameters for the motor. Yes, generally we see that the motors are generally rated in BHP. BHP is brake horsepower. This is the power with which the motor can supply the voltage and speed. How much it can supply the voltage and the speed. So the motor, generally the input power for the motor is always greater than that of the output. That is because there will be lot of losses such as iron losses and copper losses. It could be in the armature, it could be in the armature, it could be in the field, and because of the frictional losses also, that we can see that the input is greater than the output. So how do we determine the input? uh, if you have to determine the input to the motor for wiring calculation, these losses need to be calculated separately. It has to be determined, and but generally the input is determined in a simple term by using the efficiency of the motor. That will, you know, that the efficiency of the motor is represented by output by input, and knowing the efficiency you can find out the input. That is, what is input equal to output divided by the efficiency. Generally the output is represented in BHP. I told you BHP has to be converted into wattage by multiplying by 735.5, which will convert the BHP into wattage. That is 1 HP or BHP, 1 HP, which is metric, is equal to 735.5 watts. So using this we can find out the input power. You can see the input power is determined by using this formulae. So if it is below 1 HP, 50 to 65% of the efficiency could be assumed, because it varies. If it is below 1 HP, efficiency varies between 50 to 65%. While a motor having 1 to 2 bhp, it will have a motor efficiency as 70 to 75%. And anything from 2.5 to 5 HP motor can be presumed. If is not given in the data, we can presume the data of the efficiency of the motor of around 75 to 80%, and any large size motor gradually raising the efficiency up to 90% can be presumed. Special motors, special purpose motors or the modern motors can be generally designed for higher efficiency, and so the efficiency can be higher than the 90%. This is how we determine the input power. But how do we determine the input current to the motor? We know that BHP, or the output, is equal to root 3 times VLIL cos phi. Using the same formulae, that is output by input, and input is equal to root 3 times VLIL cos phi, VLIL cos phi. Substituting the input value here, you have to find out the total rated current. The rated current helps us to determine the cable size. Unless the input current to the motor is known, otherwise it will be tough for us to find out the cable size. So suppose there also we have different, if it is a DC motor, the current, the voltage formula is different. For example, if you have a 500 volts 10 HP motor, but it is a DC, then the formula used to find out the current is, since it's in HP, you have to convert it into wattage divided by 5 VI. That itself is the formula for the DC current. So I can find out the current directly. Considering since it is 10 HP motor, efficiency can be considered as 80% and the current can be calculated. Say it will come up to around 18.4 amps. With the same, this is for DC motor. In case you have to calculate the input current for an AC motor, then you'll have to consider the power factor also. Power factor can be presumed of around 0.75 to 0.9 depending upon the size and the type of the motor. Input current for a single phase AC motor can be determined using the formula. Input current can be found out using the formula rated BHP as usual, because BHP is the rating size, rated BHP into 735.5 divided by, since it is a single phase motor, I'll have to have the supply voltage is 240 volts and I told you the efficient power factor is around 0.7 and the voltage is 240 volts, power factor is 0.7 and efficiency could be considered as 0.8 and the current can be calculated likewise. And suppose if it is a three-phase motor, what would it be? If it is this is single phase, if it is three-phase motor, how to calculate the input current? For that, once again the formula lies the same, except that instead of single phase we'll have three phase. Root 3 comes in. It is rated BHP into 735.5 divided by root 3 times that of the voltage, efficiency into VL into cos phi. Using these formulas, whether it is a DC motor or a single phase motor or a three phase motor, likewise the formula keeps changing. This is how you determine the input current to the motor. Okay. Now how do we determine the rating of the cable? See, when a motor is started, it draws large current, larger than that of the full load current. So IST is definitely greater than the full load current. Since this excessive current is only for a short period of time, in case of large motor, it is limited by various devices. So here we shall not consider the starting current. It need not be taken into account while determining the size of the wire or the cable. So it will be chosen, the cable size will be chosen based on the full load current itself. So the size of the cable as according to this data I have given, if it is a 10 HP motor and 500 volts DC, so you can find out the input current using the formula. You will get at around 18.4 amps. Using the table, looking at the table, you can find out the cable size that is required, that is 7 bar 0.915 mm if it is copper, 28 amps capacity, and if it is 2 HP 240 volts AC motor, then input current will be around 10.95. This cable size of copper 3 bar 0.915, and if it is aluminum it is 1 bar 2.8. And if it is a single phase, now if you consider a 3-phase AC motor of 10 HP 415 volts, calculate the current. Suppose the input current is around 15 amps, and based on that you can, looking at the table, using the table and the input current, locate the cable size for that particular, whether it is copper or aluminum. You, according to the requisition, you can find out the rating of the cable. So if you have to find out the conduits and the distribution board, the number of cables of different sizes can be accommodated, can be found out by using the number of circuits, how many ways, what is the voltage rating, and what is the distribution board, and the current rating will be the capacity to withstand the starting current. This is how you determine the input power, the current, rating of the cable, size of the conduit, and the distribution board. I hope you understood this session, where consecutive videos can be referred for further concepts. Thanks for watching.